Hello and welcome to this introduction to the nRF5340 SoC and nRF Connect SDK. This is a session that's a part of the Garmin Developer Virtual Conference. My name is Björn Kvåle. I'm a product marketing engineer at Nordic Semiconductor. I've been with Nordic for 5 years, a bit over 5 years now. So I started off in the tech support group. Worked there for roughly 2.5 years, and then I moved over to product marketing after that. So just a quick agenda. So first off, what we'll do is I'll give a quick intro to the nRF5340 SoC before we move on to a more detailed introduction to the nRF Connect SDK. I'll talk a bit about the evolution of the nRF Connect SDK from the nRF5 SDK. Give an introduction to real-time operating systems, and then we'll go more into the details of nRF Connect SDK. Just a quick note on our portfolio on the low-power short-range wireless side. So you're probably aware that we both have an nRF52 series and an nRF53 series, a bunch of different protocols that we support, so you can see some examples there, in addition to, of course, ANT and Bluetooth low energy support. On the 52 series side, we have everything from the flagship nRF52840 all the way down to the nRF52805. And of course, a bit in between, there's varying features and also varying price points there. And now we have our new flagship nRF5340. And this is the sort of the main SoC I'll be talking about during this presentation. So let's go right on into the nRF5340 SoC. A quick overview and highlights. So you do have two processors. You have an application processor in addition to a network processor. And I'll talk a bit more about the benefits of having a dual core system later on in the presentation. We do have a 128 megahertz ARM Cortex M33 on the application processor side, in addition to 1024 kilobytes of flash and 512 kilobytes of RAM. On the network processor side, we have a 64 megahertz ARM Cortex M33 with 256 kilobytes of flash and 64 kilobytes of RAM, in addition to the multi-protocol 2.4 gigahertz radio. And I'll talk a bit more about that radio later on. On the network processor side, it is fully programmable and also ultra low power. And the good thing about that, normally the network processor cannot be freely programmed and only specific images, precompiled images can be used. But on the nRF5340, you do have full flexibility to program both processors the way you want to process them, the way you want to flash them. And in that way, you can put whatever code you want on them, and it provides a very flexible solution in that sense. On the radio side, it is a redesigned multi-protocol radio. So the radio interface and protocol is very similar to the 52 series, but the radio itself has been redesigned quite a lot. So there are significant sensitivity and power consumption improvements, which I'll talk about a bit later. On the advanced security features, we do have trusted execution, root of trust, in addition to secure key storage on the nRF5340. And the 1.7 to 5.5 volt supply range is great for both rechargeable batteries or if you want to power via USB 2. And the extended minus 40 to 105 degrees Celsius operating temperature, that's very good for some commercial and industrial applications such as professional lighting. So let's move on to the multi-core flexibility. So the great thing about having two cores is you can have both high performance and high efficiency and no trade-off between the two. So generally there is a trade-off when designing on a single core, but seeing as you have two cores, what we've done is basically the application core was designed and optimized for performance, whereas the network core is designed for efficiency. The great thing about this architecture is you do get a separation of concern. Most wireless embedded devices have real-time requirements, so the radio has to follow the timing provided by the wireless protocol. Interfaces may need to, drive a motor or a display, for example, and this can lead to compromises if you're on a single core. Whereas with this dual processor on the nRF5340, the network core can handle the real-time requirements of the wireless protocol, and that lets the application processor handle the rest. There is also a benefit to having a software split. So what you can do, you can have a thoroughly tested wireless protocol stack on the network core, and you can develop your application on the application core. Another example would be if you want to develop and sell a proprietary wireless protocol stack or add-on, you can test that it works correctly on the network core, and then you can provide an API to the application on the application processor if you want to do that. That's a possibility there. Let's move on to the multi-protocol radio. So it does support Bluetooth 5.3 and beyond. We also do have Bluetooth low energy and ANT support on the radio, and I'll talk a bit more about this later on. And we do also support all of the other Bluetooth low energy features from 5.0, 5.1, 5.2, 5.3. We are part of the Bluetooth SIG working groups, so we know what is coming and we can design for it too. And that is all I wanted to say there. Moving on to the radio improvement side. So the TX current has been reduced with 29% down to 3.4 milliamps. This is compared to the nRF5340 SoC, and all of the comparisons are done with 0 dBm TX output power, 3 volts, and DC using the DC-DC regulator. On the RX current side, we've reduced that with 41% down to 2.7 milliamps compared to the nRF52840. So the RX sensitivity is minus 98 dBm, which is actually 3 dB better than the nRF52840. So basically the nRF5340 provides 3 dB better sensitivity while using 41% less current. And another good thing, of course, of having a low RX current, it's very beneficial if you're receiving streams of data. And another good thing is you do have 1 dB of resolution of the TX power. So compared with the nRF52840, there the TX power is basically whatever dBm value is set plus minus 4 dB. So there is a risk of overshooting regulation when you are using the power amplifier. Whereas now, seeing as you have 1 dB of resolution, you can set the TX output power to be a bit, so the TX gain, you can set it a bit more towards the regulation limits, seeing as you have a 1 dB of resolution compared to the 4 dB on the 52840. And the reason we're comparing this slide with the 52840 is that that was our previous flagship SoC. So of course, if you want to compare this to other 52 series, the radio improvements are most likely even better. Now moving on to security features. So we do have the security features I want to mention here are cryptographic services, secure storage, runtime isolation, and secure boot and secure update. And here you can see the white box, that's hardware features, and the blue box, that is software features. So starting with the cryptographic services. So these services maintain the security of data and protect communications with remote services. The CryptoCell hardware supports both symmetric and asymmetric schemes for encryption and decryption of data, in addition to signing and verification services. The CryptoCell 312 cryptographic accelerator is used in the nRF5340, and the PSA APIs provide a standardized interface for this. Moving on to the secure storage. So here it does provide secure key storage, handling, and revocation. The key storage is in one-time write protected flash, and the key management unit manages the secure key operations. Again, we do have PSA APIs for this. Moving on to runtime isolation. So this provides runtime isolation of security critical software, data, and peripherals. We do have trust zone hardware enforced isolation here. You can see that there. And trusted firmware M provides the secure processing environment. And last but not least, secure boot and secure update. Here we have immutable and updatable boot partitions to enable feature and security updates while maintaining the integrity of the product. And here we do have, we're also using, you have the secure partition and the SPU here, and you're using MCU boot on the software side. Okay, so moving on. So basically the nRF5340 it's kind of like a Swiss Army knife in that it is an all-in-one. It does provide all of the nRF52 series feature supersets. So you have Bluetooth 5.3 support, you have ANT, Thread, and Zigbee. It has the crypto cell, hardware accelerated cryptography. It has USB, quad SPI for flash, and also high-speed SPI for running displays. In addition, you have the 1.7 to 5.5 volts operating range and up to 105 degrees extended operating temperature, and that's in Celsius. So essentially what you get is you get more performance, memory, and integration while at the same time minimizing the power consumption compared to the 52 series. Okay, so now I'd like to talk a bit about the markets and applications and what the nRF5340 can be used for. So of course, one of the main use cases is advanced wearables. So here you do have a high performance 128 megahertz processor with DSP instructions and also floating point capabilities. You do have 512 kilobytes of on-chip RAM for data, also for sensor fusion if you wish to use that. You have a memory mapped 96 megahertz encrypted quad SPI interface, great for external memory. And you also have a 32 megahertz high-speed SPI for displays and fast sensors. Sensor collection in application or network processor, that depends a bit on the bandwidth. And in addition, on the packaging side, you have a compact CSP with few external components. One thing I'd also like to highlight on the application side, that is, of course, machine learning. And we do have a partnership together with Edge Impulse, which basically makes machine learning a lot easier to use, especially for engineers that are not that well versed in machine learning and artificial intelligence. So we do have a Thingy53. I'll talk a bit about this prototyping platform. So if we look at the hardware diagram here, so you can see we do have the nRF5340 SoC on the Thingy53 PCB. We have external memory, user programmable buttons, in addition to the nRF21540 RF front-end module. We also have a digital microphone, color sensor, RGB LED. If you look at the back of the PCB, you have accelerometer and gyroscope, humidity, temperature, pressure, and gas sensor, a low power accelerometer, magnetometer, also our own PMIC, power management, and more. So this is a great sort of tool to use together with if you want to use machine learning. We also have the nRF Edge Impulse app, and that provides a great sort of unboxing experience for the Thingy53 and for machine learning. So this is of course using embedded machine learning together with Edge Impulse. Every Thingy53 does ship preloaded with firmware to support this nRF Edge Impulse app. We also have integration with the Edge Impulse Studio. So basically what you can do is you can use the Thingy sensor data. You can take up sensor data on the Thingy, then you transfer it up to Edge Impulse Studio. There you can make the data learning. You can use the machine learning models. You can make those on the Edge Impulse Studio in the cloud, and then you can basically transfer that. You can flash the model then onto the Thingy53 and test it. So you can use the Thingy53 to collect all of the sensor data to train the models, but you don't have to. And yeah, so then the trained models, they're then downloaded to the Thingy53 and then will run on the nRF5340 SoC with inputs from the relevant sensors depending on which ML model you have created. So this is a very great and easy way to get started with machine learning on the Thingy53 using the nRF5340 SoC. So yeah, you can, of course, and the great thing about this is it does provide rapid machine learning prototyping. I mentioned most of this already. You also have wake on event sensors, and you can do over the DFU for the ML models through the app itself. So I think the best thing here is just buy a Thingy53 and test it out for yourself. It is a very cool way to get started with machine learning. Okay, so now I'll go a bit more into the details on the nRF5340, and the idea here is to provide this more as a reference for you later. So that is the main reason why I've added this here. So I won't go through all of this, but I'll go through some of the highlights here. So of course you have the application processor. One thing to note here is we do have voltage frequency scaling. That might be interesting. We have trust zone support and a lot of RAM, flash and RAM. So 1024 kilobytes of flash, 512 kilobytes of RAM. Network processor, I've mentioned most of this. Again, this one's optimized for efficiency, while the application processor is optimized for performance. You do have multi-core flexibility, so that is very useful. So you can, for example, run, here you can see the application core. You can run it at 128 megahertz if you want to do so, and then you'll get more performance. Or you can run it at 64 megahertz to get a bit less performance but more efficiency. The network core is, as you can see, it's running at 64 megahertz, and it is the high efficiency core. So yeah, just wanted to quickly mention that you can run the application core at different frequencies if you want to do so, depending on your application. Power and clock, you do have LDO and DC-DC options here. You can also have direct supply from USB. And packages, this is good to note. We do have an AQFN94 with 48 GPIOs, which is in mass production. That's 7x7 millimeters. But we also do have the 4.4x4 millimeter wafer level chip scale package 95 with 48 GPIOs. Okay, let's move on to the software support. So the nRF Connect platform, this basically is a unifying platform that supports all of our Nordic ICs. We also do support all Nordic wireless technologies. So I think the two most relevant here are Bluetooth Low Energy and ANT, but we do also support Thread, Zigbee, LTM, Narrowband IoT, etc. So this basically provides a complete solution from board to cloud. So of course you have the nRF Connect SDK, which I'll talk more about later, but you do also have supporting components such as hardware design and development kits. You do have world-class PC and mobile tools, so that includes nRF Connect for desktop, for example. You have an nRF Connect for VS Code ID. I'll talk a bit more about that later, and you also have cloud applications and tools. And this also includes, partner tools such as the Edge Impulse Studio, for example. We do have a modern real-time operating system integration for complex designs. We use open source when and where it makes sense, and we do also have a very modern development and distribution model. This is a very scalable solution too, so it is both for low and high complexity applications, and it will work for single core or multi-core SoCs. So the idea here is by providing all of this, it lets you, the developer, focus more on the application and less on the other things. Okay, so just a quick introduction to the nRF Connect SDK. This is one codebase and toolchain for the nRF91 nRF70, nRF53, nRF52, and nRF21 series. Again, most relevant here, ANT and Bluetooth Low Energy support, and the Bluetooth version 5.3 qualified host and controller stack that has been in there since version 2.0.0. Right now we are at version 2.1.0. Just some quick slides on the evolution from the nRF5 SDK, which you probably know quite well, to the nRF Connect SDK. So what we've basically done there is we've ported the soft device controller. So we are market leaders in Bluetooth Low Energy in large part to nRF5 SDK plus soft device. And it's the link layer, which you can see down here in the controller subsystem, that enables best-in-class interoperability between the SoC and smartphones. And it's also very difficult to get right. So basically what we've done, we have ported the soft device link layer to nRF Connect SDK to ensure that we still get the best-in-class smartphone interoperability in nRF Connect SDK versus the nRF5 SDK plus soft device. So as you can see here, the standalone soft device controller library is now the default Bluetooth Low Energy controller for Bluetooth samples. So you can see the soft device nRF5 SDK, and we've taken the link layer here and moved it over here. So now we still have the radio, the physical layer. You have an MPSL layer if you're running multiple protocols, for example, Bluetooth Low Energy and ANT, a bit more on that later. And you have the soft device controller here, and then an HCI layer to talk to the Zephyr Bluetooth Low Energy host. Okay, just a quick slide on Bluetooth Low Energy. So we are using the Zephyr Bluetooth Low Energy host. I'll talk a bit more about Zephyr later. The good thing about this does reduce complexity in the API, and we have the soft device controller, which then inherits the maturity and interoperability from our soft devices. And we do contribute, test, and certify the whole Bluetooth Low Energy stack. And we do provide QDIDs for product listings. They work as with the soft devices. And the nRF5340 has been qualified since the version 1.6.0 of nRF Connect SDK, which was quite a while ago. Talk a bit more about Bluetooth Low Energy software flexibility here. So this also works for ANT too. So as you can see here in the network core, we have both the soft device controller and ANT here. And then you're using the HCI RP message layer to then talk between the application core and the network core. And on the application core, you have the Bluetooth LE host and the Bluetooth LE sample. Moving on to the code base. So the code base does contain application code, connectivity protocols, wireless stacks, and peripheral drivers. You can see here on the right hand side we have some code. So the purple layers, that is open source code, and the blue layers, that is Nordic source code. And the code is organized into several repositories, both Nordic and open source code. So board configuration, that contains things such as device tree, which I won't go into detail on here, but basically how you want to set up your board, how you set up the GPIO mapping, etc. You have a different layer then for the Zephyr RTOS kernel. The wireless stacks and peripheral drivers are down here. Middleware, this could include your own customer code, for example. And we do have connectivity protocols, also security libraries and device firmware updates, in addition to the Nordic applications on top. And the idea is that we do provide a lot of applications and sample code to make it easier for you to get started making your application, and you don't need to make it from scratch. So just some few quick slides on the nRF Connect SDK repositories. We do have the nRF repository, which is mainly application and connectivity protocols. We also have the nRF which are compiled libraries where Nordic cannot distribute source code. nRFX, that's mainly peripheral drivers. Then we also have the Zephyr repository for things such as the real-time operating system and also board configuration. So that would be those two layers on the bottom here. MCU boot, that is the secure open source bootloader, and some other relevant repositories, trusted firmware M, Matter, Ant, etc. So moving on to the Nordic software. So the main SDK repositories, that's the main repository with samples, applications, and connectivity stacks. So this is split up into multiple repositories, but the idea here is the source code is exclusively written by Nordic Semiconductor, and it's then licensed with a permissive Nordic 3 clause or 5 clause BSD license. And the reason we have multiple repositories here is that it does provide a clean way of code separation, so that changes to the Zephyr project repository, for example, don't affect the Nordic Zephyr repository, for example. And basically what the permissive license means is that you do have minimal restrictions on use and distribution. And here you can see a bit more what's below the surface here. So you do have multi-protocol, for example. You have the Bluetooth low energy link layer down here, and up top here you have multiple applications, samples, device firmware update, in addition to the secure partition manager, for example. Okay, moving on to the open source software. So that's these layers here in purple. So the nRF Connect SDK redistributes the open source software for standard platform components. So instead of us spinning the wheel and doing things again, which already work very well in open source, for example, a lot of protocols, those have already been defined and tested heavily inside Zephyr. So there we will use open source where we best see fit, and we'll write our own source code where we best see fit. So we do collaborate with communities of industry experts to deliver these components as part of the nRF Connect SDK. And these repositories, these open source repositories, are licensed with very permissive license, for example, Apache 2.0. And here you can see a bit more in detail. So you do have board and device configuration here. Device tree, I mentioned that quickly. You have the RTOS kernel itself, in addition to a lot of other files. So the Bluetooth low energy host, for example. You do have, this is not so related here, but it's good to know that you do have UDP TCP support, crypto APIs. The West YAML file is essentially a file inside the nRF repository that says which version of the other, which commit of the other repositories that will be used in that version, in that release of nRF Connect SDK. And what we do is, so Nordic does synchronize with external repositories. So you can see the external repositories here. So we synchronize with them, we also contribute to them. So the nRF Connect SDK is a single platform. All of the source code is distributed by Nordic, and this does include open source code from external projects such as Zephyr. And then we contribute and synchronize with these external projects. We also run integration tests on all of the source code and manage configuration. And then you as the customer, all you really need to do, you can access this easily via West and Git. Okay, a few quick slides on real-time operating systems. So what is a real-time operating system? So the goal, at least, of a real-time operating system is to ensure predictable and deterministic execution patterns. So embedded systems often do have very strict timing requirements. The scheduler normally decides which task to execute at which time, and then that's achievable by setting a priority for each of the execution threads. And here you can see the RTOS kernel is down here inside the entire figure here. Why would you want to use a real-time operating system? So one good thing is you do have a separation of concern. So you can build modular code, and you can then use the same modules which provide a certain functionality in different projects, provide certain inputs and output, for example. Separation of concern is also good. Let's say you make a change in one of the repositories so that it doesn't affect all of the other repositories too. But that is in essence good. One of the good things with a real-time operating system. You can also control the application complexity in large memory devices. If an RTOS is used properly, it does provide a higher level programming module, so it should provide a faster time to market too. And one of the good things also of a real-time operating system, it does work for very small devices, but also works for, multi-core, very complicated and memory intensive applications too. And a few slides quickly on the Zephyr project itself. So that is designed and built for low power wireless. It is an independent technology project that's governed under the Linux Foundation, and contributions are made by over 1,000 industry embedded experts. Zephyr is very scalable, so it has very small configurations for memory constrained devices. So for example, 8 kilobytes, like a simple LED blinking application, but it also provides enough features for very powerful, feature-rich configurations for large memory, high processing power devices. That's multiple megabytes, but also if you have multiple cores too, that can also be supported. And Zephyr does include a lot of the fundamental pieces of code, which lets us focus on a lot of the other important features. So for example, two examples are, let's say, MQTT and CoAP. Zephyr does this very well, so that lets us focus on other features. Zephyr also does, that was already mentioned, and Zephyr has been developed with a focus on security. So they do have their own product security incident response team, and that team fixes security vulnerabilities and notifies the customer and the public too. Okay, moving on to the nRF Connect SDK, a bit more of the details there. Here I've provided a link to the documentation, and we will provide this presentation as a PDF, so you can click on some of the links here to get more information. In the documentation, if you go to the top right corner, you can see this here, and here if you click on this button here, you can then switch between the different versions of the documentation. So the latest tag right now is version 2.10. The reason you don't see 2.10 here is that we've recorded this before version 2.10 has gone out of the nRF Connect SDK. So the 2.0.99, the 2x.99, that refers to the main branch. So that is essentially the latest state of development. And you can also see these tabs on the top there. On the tab banner, that's where you can switch between the different repository documentation. So for example, nRFxlib, Zephyr, MCU boot, or other documentation pages. Release cycles. So we do have regular releases on a quarterly basis. It is publicly hosted on GitHub. I've provided a link there. But you don't need to, you can download via an app called the Toolchain Manager, and that's provided in nRF Connect for desktop. So that's an easier way of obtaining the code than, a very simple way of obtaining the code. Very few button clicks needed. Fixes are released as needed, and long-term supported releases can also have fixes applied and delivered after new releases. So there's an example of that here, for example, right? So this fix here came after the minor tag. We do also have the latest development version available. That is the main branch. So a good thing here is if you want to test out a new feature that hasn't gotten into the last tagged release, you can always test it out on the main branch first, and then once your feature is out in a tagged release, you can then move on to the tagged release. The version control management is done with Git, and that is for managing new version and also fix adoption. And the tool does support merging too. One thing to note, the main release has not been tested as well as the tagged releases then. So in addition, unless you need the latest features, it's always a good idea to download to clone the latest tagged release and not use the main branch. On the ID support side, we do have nRF Connect for VS Code. That is built from the ground up for nRF Connect SDK. It is an extension to the very popular VS Code ID. It's highly extendable, highly configurable. It does have a command line interface in addition to a GUI interface. There is cross-platform support for Windows 10, the latest version of macOS, and I believe Linux, the latest version of Ubuntu Linux. I think it's 20.04 if I'm not mistaken, but they're also testing out the 22.04. But just check out, we have our own documentation for that too. So there's more information there. We do also have a new board wizard if you're using your own custom board. So that's an easy way to, set up a new board. And we do have a rich set of tutorial videos which are provided at the link here. And this is the main IDE we recommend together with nRF Connect SDK. So we do also have a fundamentals course. This is a self-paced, hands-on online course that's focusing on learning the essentials of nRF Connect SDK. Good thing about being self-paced is you can do it whenever you have the time to do it. We do have a lot of hands-on exercises. We also have a centralized up-to-date content, and we do have a team of 3-4 people that do work on the nRF Connect SDK, mostly full-time. It is protocol agnostic, and it does support all of our DKs in addition to the Thingy 91. I believe the Thingy 53 is supported too. And it is very ideal for new users of the nRF Connect SDK, or also users switching from the nRF5 SDK to the nRF Connect SDK. And last but not least, you can also test your knowledge through interactive quizzes. And here's a QR code. Otherwise, you can also just search. I think if you just search Nordic Dev Academy, you should be able to get to the course there. So just a quick summary slide here. We do provide the complete development solution for we of course have the nRF5340 SoC, but then we also have the nRF Connect platform and the nRF5340 DK. So the nRF5340, multi-core flexibility, one application core that is more performance oriented, one network core that is more efficiency oriented, supports Bluetooth 5.3. We also have ANT support now. We do have Matter and also next level security. One thing I forgot to mention regarding multi-protocol Bluetooth 5.3 and ANT support, that's not available right now, but it will be available soon. And Daniel will talk a bit more about the development side of things, how you can run a ANT example and sample using the nRF5340. But just good to know, if you want to use Bluetooth Low Energy and ANT, multi-protocol support will be coming soon. On the nRF Connect platform side, you have the nRF Connect SDK, nRF Connect for Desktop, which is a various apps available for Windows, macOS, and Linux. So that's Windows 10, latest version of macOS, and the latest LTS version of Ubuntu. In addition to the toolchain manager, which I quickly mentioned to download the nRF Connect SDK or clone the nRF Connect SDK. We do also have a programmer app if you want to program, let's say, the nRF5340 DK or the Thingy 53 via a GUI interface. We do also have, Flash layout interface to show what regions of Flash your application is using. We have nRF Connect for mobile, which is similar to nRF Connect for desktop, just using mobile apps. So I mentioned the Edge Impulse app. We also have nRF Cloud, which is a cloud development platform there. And of course, we have the nRF5340DK, which uses the nRF5340 SoC, and it does support all of the features of the nRF5340 SoC. So here's some more information on the nRF5340 SoC. I provided the link for the Thingy53. We do have a webinar on the nRF5340, might be worthwhile watching. And here's the link to the Academy if you want to get started with the nRF Connect SDK Fundamentals course. So yeah, that is all for now. Let's move on to the Q&A.